Hey Monique, I think where you're having trouble, because this is exactly right. You remember to flip it when you divided by a negative. So this is totally the right answer. I think where you're having trouble is getting from this form into that form. So let me show you a little bit with that. First off, this first one is right. It would be a bracket on the 15 because it's an equals, and I'll show that on the next example. Um, but all this one would need to be corrected would be a bracket on the 15. So let me do this one and this one because they're like each other, but they're kind of reverse. So for this first one, we'd have 20x plus 23 is greater than or equal to 0. And no matter what's going on under there, that's our plan. We just take whatever's under the radical, set it greater than or equal to 0, because we can't take the root of a negative number or not an even root. And then we solve and we see what happens. So for this one, looks like you did your solve right. So you brought your 23 over greater than or equal to negative 23. And then you divided both sides by 20. And that got you x is greater than or equal to negative 23/20. So for me, what helped when I'm working this out, even if I don't draw the graph, I'm picturing the graph in my head. So if that was my graph and this was negative 23/20, and then I would use a solid endpoint along with a bracket when I go to write the interval notation because of that equal sign right there. And this reads x is greater than or equal to negative 23/20. So if the x's are greater than or equal to, or they're bigger than this number, that means they're going to be on this side of that endpoint, because that's where the bigger numbers are. And when we go to write interval notation, we always start at the farthest left and then work to the farthest right. So in this case, the farthest left is this negative 23/3. So that's where that bracket comes in because of the equals and the solid. Those all go together. And then that goes on to out here lives infinity. So that goes to infinity. And infinity is always a parenthesis. So that's that one. This next one has, I'm going to do the same thing as you right here. 29x plus 26 greater than or equal to 0. So that comes over. We have negative 29x greater than or equal to negative 26. And then you totally divided both sides by that negative 29 and even remembered to flip that, which is great. So that gets you x is less than or equal to, and then double negative, so that'll be a positive 26/29. So now if I think about that one on a number line, again, I'm just going to, there's my dot, I'm going to call that 26/29. Oops, 29ths. And then where are the x's less than this value would be going this way. And so out here, this is negative infinity, and this side was positive infinity. So if I start at my leftmost point, that's negative infinity. And then that goes up to 26/29. And again, the bracket because of the equals and the solid dot. So it's that negative is where it's changing it up. But again, I think it's the seeing this notation and being able to figure out kind of visually which way that goes. Here's kind of a little dumb cheater thing, but it works pretty good. Notice if I drew a little arrow in there, it goes the same way as the graph. So when you're just looking at this part, x is greater than this, you can kind of think of, I'm starting on this point and it's going to go this way. Again, if you look at the arrow on the graph and the direction of the inequality, they also go the same way. So if that helps you to go, this graph would go this way, and then this graph goes this way. Again, it's not real math, but sometimes just a little visual cue like that helps. Hopefully that helped clear that up.